Okay, so this is your worksheet that we were working on yesterday. We're going to continue to work on double replacement reactions. I'm going to do a few more for you. So again, when you're doing your double replacements, one of the ways to start off is to put your charges up above. So aluminum is a +3. Again, if you don't have that marked on your periodic table, then maybe that's something you need to do. Aluminum is a +3. Okay. The other thing is your sulfate. Come to your periodic table. Your sulfate is a 2-. Okay. Calcium. Okay. Is a 2+. And phosphate. It's right here, and it is a 3-. Okay, so I've got my symbols written on there. The next thing that I am going to do is to go ahead and we're going to do our switcheroo. So my positive cation will attach to my negative. So aluminum, which is a 3+, I'll put that lightly up above, will attach to my phosphate, which is a 3-. Now I have a 3+ and a 3-, so that was the writing formulas that we just worked on if you watch those videos. So I do not need 3+, 3-. I do not need any subscripts. One of each is all I need. Plus, now again, I start with my positive calcium and my sulfate. So calcium was a 2+. My sulfate is a 2-. Again, when I look at it, I have a 2+ and a 2-, which is already zeroed out. So I am done with that. Okay. Now, for the problem that we're doing, since we're doing a double replacement, we're trying to figure out if one of these is the precipitate or not. So we're going to go to, again, the table here. I'm going to be looking for aluminum and phosphate. So here is, scroll down just to here. Okay, aluminum and phosphate. And it says I, which means insoluble. So that means that this is going to be a solid. Sorry, can't see that. So that's going to be a solid. I'm going to do calcium sulfate. So calcium sulfate is all the way over to here. And where's it at? Right here. It is also insoluble. So in this case, what we're going to see is one solid chunk. So we're not going to have any liquid. So where when we had just the single precipitate, we saw the precipitate here, and then we saw the aqueous solution up here. In this case, we're not going to be able to distinguish because it's going to make one precipitate. And so we'll not be able to determine which is the aluminum phosphate and which is the calcium phosphate, but we will definitely see a precipitate. So we would not be able to separate this one out. Okay, I'm going to do one more off of this sheet just so you have a sampling. So I'll go ahead and do number 10. Again, silver is a +1. You can look at that on your chart. This is your acetate. If you don't know it, you just have to go looking for it on your sheet. So here it is, acetate, and it is a -1. Now that is that whole piece right there. We have potassium, again from your periodic table, which is a +1. Get it all down. And then we're going to look up chromate, CrO4. Again, if you don't know those, you're just going to have to look for them. Chromate, and it is a 2-. Okay, again, as a double replacement, we're just going to do our switcheroo. So our positive is going to attach to our negative. So I have silver, which is a 1+. I have chromate, which is a 2-. Now this goes back to what we were doing earlier. If you watch the other videos on naming, I have 2 negatives. I only have 1 positive. So I'm going to need, if you think of it this way, I'm going to need another positive. So I have 2 there. Now I'm not going to leave that there. I'm just going to write a 2 here to show that. And then I would probably get rid of that. Okay. Or again, crisscross. That 2 comes here, the 1's going to come there. Okay. Next, then I have my potassium and my acetate. Potassium's a +1. My acetate is a -1. So I'm not going to need any subscripts because those are going to cancel out. Okay. So now I need to see if one of them is a precipitate or maybe both. So silver chromate. Let's see if that one is even on here. Oops. Slide that down so we can see it. So silver is going to be right down there at the bottom. But let's see. Chromate. I don't remember if it's on here or not. It is not on there. So one of the things that we would need to do would be to look that up. Let's go ahead and go to the next one, which is acetate. So potassium acetate. Okay. And potassium again's down here at the bottom. Acetate's up there at the top. So potassium acetate, that is soluble. Okay. So in order for us to determine if silver chromate is, that might be one, since our chart doesn't show it. Some of the charts actually show it, or if you learned a rule. But if you didn't know it, you could definitely look it up and see what it is. Is silver chromate. See, I'm going to do just a quick search. Soluble. So, and it says it is sparingly soluble, has a solubility product, varied. So it is soluble from what they're saying. So could be that it is, oops, sorry, I put an S over here, my bad. That was insoluble, or soluble, so it was aqueous solution. And then also this one. So in this case, this would again be our no reaction if we had both of them being aqueous. So again, let me back up to this potassium nitrate. So potassium, not nitrate, potassium acetate, sorry, soluble. Okay, soluble meaning aqueous solution. Okay, so that is just 2 more off of your assignment sheet. That, and I'll do 1 more. And then again, you are to be finishing these yourself. So we'll go ahead and do, I'm going to do 13. Okay, just because I want to show you something here on 13. So we have lead and nitrate, and lead is one of our transitions. Okay, it's going to be over here. A transition, we really don't know its charge because it could have multiple numbers. So what I'm going to do is I'm going to backtrack to figure out what it is. So I'm going to look up the nitrate, which is up here. NO3, it's a -1. So let's watch again how I do this. This is a -1. There are 2 of them. That means that this has to be a -2 overall. That means my lead, in order for this to work, has to be a +2. So we can backtrack and figure out what the lead is if they don't give it to us. The next one is hydrogen and iodine. So hydrogen is going to be my +1 because it's on the left. My iodine is a -1. Okay, we're going to do our switcheroo. PB. It's going to attach to our I. PB is a 2+. Iodine is a 1-. Again, as our discussion earlier, we've got 2 of these, only 1 of these. I'm going to need another 1 to get 2. So I put a 2 there. It means I need 2 of them. hydrogen with our nitrate. Hydrogen is a +1, nitrate's a -1. Again, as I told you earlier, anytime it starts with a hydrogen, it's going to be an acid. Since this is a polyatomic, we call this nitric acid. Nitric acid. That over here so you can see it. Okay. Again, let's check our solubility. So all acids are aqueous. That's a given. So it's just whether or not lead iodide is insoluble. So let's go find that out. So we have lead, and we figured out it was a lead 2 and iodine. Lead 2. I lose my track here. And iodine or iodide, because that's what it would be named. It's insoluble. So that means that that's going to be our solid. So we are going to see, in this case, we are going to see lead, iodine is going to be down here, and our nitric acid up there. Okay, so this would be our precipitate. Okay, again, reminder that you are to finish 1 through 15 on this page.